We're looking for the distance traveled by x of t from 2 to 5. First, we will be looking for the velocity function. So x prime of t is equal to v of t. V of t, the first derivative, will be 3t squared minus 2 times 6, 12t. V of t is equal to 0. We set the derivative equal to 0, which means 3t squared minus 2t is equal to 0. 3t times t minus 4 is equal to 0. We will be looking for the critical values, the 0 of the derivative in this particular instance, and it's t equal to 0 or t equal to 4. Now, on the number line, 0 and 4 are the zeros of the derivative. We realize that when we test for, let's say we test for 2, the velocity will be negative. 3 times 2 is positive, and times 2 minus 4 negative. So the velocity is negative between 0 and 4, which means the particle moves backward to the left. And then when we test after 4, we test for 5. 3 times 5 is positive, and 5 minus 4 is positive. After 4, the particle is moving right, moving forward. Since the particle changes direction after 4 seconds, we're going to calculate two time intervals, and we're going to calculate them separately. So it's going to be from 2 to 4. Let's call it the first distance, and then from 4 to 5, which is the second distance. So the total distance will be s of 4 minus s of 2, position of 4 minus position of 2 in absolute value, and then s of 5 minus s of 4. The absolute value of s of 5 minus s of 4. Now, briefly, we will show you that s of 4, according to the position function x of t, is 4 cubed minus 6 times 4 squared plus 1. Therefore, s of 4 is negative 31. Similarly, s of 2 is negative 15, and s of 5 is negative 24. Now, the distance, the total distance, will be the absolute value of negative 31, s of 4, minus negative 15, s of 2, plus the absolute value of s of 5, negative 24, minus negative 31, which is s of 4. So it's the absolute value of negative 16 plus the absolute value of negative 7, which is 23. 16 plus 7.